So guys, soon after we have seen the nucleophilic substitution reaction of our haloarenes, today we are going to see a concept called as an electrophilic substitution reaction. Electrophilic substitution reaction. So in order to understand this electrophilic substitution reaction, I would like to recall the concept of my nucleophilic substitution reaction. That is, when we were explaining that, why does our haloarenes are less reactive towards the nucleophilic substitution reaction? There we have given many steps, or we can say many points. It could be a resonance effect, it could be the electron density, it could be a hybridization of the carbon atom. So through those points, I would like to choose the resonance effect of our chlorobenzene. So basically, whenever I am doing or when I am choosing the chlorobenzene, yes, of course, during the resonance effect, what did we say? This chlorine atom has a tendency to donate the electrons. So it acts as an electron donor. And when it happens, of course, we are going to get the various resonance structures in which we are observing that our C and the Cl bond is double bonded, and in turn what happens, since here now electron density increases, this pi electrons will be, that electron density will be taken by this carbon. So therefore I would be getting a negative sign over here. Yes, as usual, here one bond and here one bond it will be. But it will not stop, okay? Because these electrons, the lone pair of electrons in the chlorine atom is interacting with the pi electrons of your benzene. So now this negative will be forming a pi bond, whereas this pi bond will be taken by this carbon, leading to an carbanion. So there once again, what I would be getting, yes, good, double bond Cl. Here it has been formed a bond, here as usual the bond was there, whereas this bond has been taken by our carbon. Again now, this would be given, this would be pi electrons will be taken by this carbon. So you will be having like this structure, yes, double bond Cl, here negative, here one bond, here one bond. But as usual now this would be given, oh sorry for that, since chlorine has been given, here all the cases will be having a positive charge on the chlorine. And one important point we have to just note here guys, remember whenever you are writing the resonance structures, make sure that you will be having an equal quantity of your opposite charges. That is, if you are having one negative charge, there should be one positive charge also. In case if you are having two negative charges, you will be having the two positive charges. So there will be maintain an equal number of your opposite charges. So now what happens? Yes, now this minus has been forming a pi bond, whereas the another bond shifts to that of your chlorine, which was formed in a double bonded between C and Cl. So the final structure we will be getting as what? Yes, Cl. But here you can see that the change in the pi bond formation. Illi avtaraytu illi pi bond idre. The final we have got in their adjacent sides. But the overall, so now this is all are the resonance structures. But in a system, how does it exist anta kelidaga? So these all will be equivalent anta ಒಂದು equivalent structure na bariತೀವಿ. So that is called as what? Resonance hybrid anta ಹೇಳ್ತೀವಿ. So that resonance hybrid, what does it includes? It includes all these structures. So how it will be? Yes, this will be your Cl. Since our pi bond is rotating, so it will be shown in this way. And see, wherever we have written the negative sign, you can just note over there where I have written in the ortho and the para position. Alva, I repeat once again what I am saying. Wherever the negative sign we are seeing is only in the ortho and the para position. That means what? So whenever we are talking about our chlorobenzene or any haloarenes, we can notice one important thing. What is that? The electron density, I repeat, the electron density will be higher in the ortho and the para position. So I would be writing in this way as my resonance hybrid. Delta minus, delta minus, delta minus. Only in my ortho and the para position. Now the question arises that, sir, of course we were dealing with the electrophilic substitution reaction. Why did we choose to write the resonance structures of our haloarenes? Alva. So if you are having this doubt, let me ask you one question. Guys, what do you mean by an electrophile? I repeat, what do you mean by an electrophile? Good. So electrophile are what? They are electron deficient species. I repeat, your electrophiles are the electron deficient species. That is, they are having a positive charge on them. Yes or no? So what we are doing? We are doing a reaction in which a substitution of your electrophile should take place. So if an electrophile should attack our benzene ring, where can it attack? Of course, where the electron density is more. And when we are seeing the resonance structures of our chlorobenzene, we are seeing that the electron density is more in the ortho and the para position. Are you thinking what I am thinking? Yes. So whatever the incoming electrophile is there, it is going to attack only in the two positions. Those will be your ortho and the para position. Is that clear? But now I am having a doubt. What is the doubt, sir? So guys, whenever we are talking about the periodic table, we say as what? Sir, halogens are highly electronegative. Yes or no? Halogens are being highly electronegative. How can we say that they are donating the electrons? Alva, this will be a question. Chemistry is not something we can change all the time. It has to follow the same way. So now my question is, when we were talking about the halogens, more particularly chlorine, of course what we know, chlorine is an electronegative halogen, is an electronegative element. Electronegative element. So electronegativity means what you can define? Yes, it is the tendency of an atom to attract the shared pair of electrons towards itself. Or simple words, it has to attract the electrons towards itself instead of donating it. Very good if anybody have got this question. But do remember guys, so whenever our halogens are attached to a benzene, it has two effects. So one, the chlorine will also have the tendency to donate the electrons, that is the lone pair of electrons, and also it has a tendency to, what you can say, attract the electrons towards itself. So whenever a chlorine is donating the electrons, that will be called as an R effect, that is your resonance effect or mesomeric effect. Similarly, whenever a chlorine is taking back the electrons towards itself, so that will be called as what? Inductive effect. Inductive effect. So once again I am repeating, whenever our chlorine is attached to the benzene or any halogen is attached to the benzene, you do remember that there will be two protocols which can happen. That is, chlorine also has the capacity to donate the electrons, which will be called as your resonance effect or a mesomeric effect, and also chlorine is having the tendency to attract the electrons towards itself, which will be called as an inductive effect. Now when I am saying this, of course now the question arises, okay sir, whenever a chlorine is attached to the benzene, it has both the roles to be played. But the question is now, which one will be dominant? Alva, which will be acting as a hero, which will be acting as a villain, which will be taking at a faster rate? So do remember guys, chlorine always undergoes an inductive effect majorly. That is, it will have the tendency to attract the electrons towards itself instead of donating. But what we have to do, we have to carry out this electrophilic substitution reaction. So in case if we have to follow this electrophilic substitution reaction, what we know, chlorine has to donate. Alva. So therefore, whenever we have to carry this electrophilic substitution reaction, we have to maintain once again the drastic conditions. What we have to maintain? The drastic conditions. Why is that? Because chlorine comparatively to that of your R effect and your I effect, your I effect will be dominating. So whenever an I effect is dominating, of course, it will take the electrons back instead of giving. So whenever it takes back, of course, the minus charge will not be seen. Electrophile will not get substituted. But I have to do my electrophilic substitution. So I have to make my reaction condition in such a way that instead of taking back the electrons, the chlorine should give the electrons. So I am making something which has to be taken place forcefully. So something has to be taken place forcefully means what I should do? Yes, I have to put some conditions. So that itself the condition is called as what? Drastic condition. So if you have to do the electrophilic substitution reactions of your chlorobenzene, we have to maintain the drastic conditions. So one important thing we came to know, what is that? So whenever we are looking after the mesomeric effect, the mesomeric effect is giving us the idea of orientation. Alva. So what is this orientation? Alva. Question arises. ಈ ಮೆಸೋಮೆರಿಕ್ ಎಫೆಕ್ಟ್ ನಾವು ಕನ್ಸಿಡರ್ ಮಾಡಿದಾಗಲೇ ನಮ್ಗೆ ಏನ್ ಗೊತ್ತಾಗ್ತಾ ಉಂಟು, ನಮ್ಮ ಏನೆಲ್ಲ ಪ್ರಾಡಕ್ಟ್ ಬರುತ್ತೆ ಅದಿಲ್ಲ ಆರ್ಥೋ ಆಗಿರ್ಬೇಕು ಇಲ್ಲ ಪ್ಯಾರಾ ಆಗಿರ್ಬೇಕು. ಸೊ ಇಟ್ ಶುಡ್ ಬಿ ಅ ಮಿಕ್ಸ್ಚರ್ ಆಫ್ ಯೋರ್ ಆರ್ಥೋ ಅಂಡ್ ದಿ ಪ್ಯಾರಾ ಕಂಪೌಂಡ್ಸ್. ಸೊ ದಟ್ ಈಸ್ ಗಿವಿಂಗ್ ಅಸ್ ವಾಟ್? ಓರಿಯಂಟೇಶನ್. ಅದು ಯಾವಾಗ ಬರೋದು? ವೆನ್ ಕ್ಲೋರಿನ್ ಇಸ್ ಅಂಡರ್ಗೋಯಿಂಗ್ ಎ ಮೆಸೋಮೆರಿಕ್ ಎಫೆಕ್ಟ್. Similarly, when chlorine is undergoing an inductive effect, it is your I effect, what the idea we are getting is with its reactivity. Alva? How slow the reaction is, how fast the reaction is. So basically through the inductive effect, we are getting the idea of reactivity of your haloarenes towards the electrophilic substitution reaction, and through your mesomeric effect, we are getting the idea of the orientation of your formed products whenever your chlorobenzene undergoes an electrophilic substitution reaction. So importantly, what we have to remember that whenever a chlorobenzene is undergoing an electrophilic substitution reaction, we are going to get mixture of two products. I repeat, we are going to get mixture of two products. And what will be they? Yes, one will be our ortho product and another will be our para product. Are you able to understand? So one will be our ortho product, another will be our para product. Now the question arises, of course sir, we are going to get two products. Whether they will be 50-50% or whether in case anyone will be higher, ಹಾಗಾದ್ರೆ ಯಾವುದು higher ಆಗಿರಬಹುದು? So first I will just clear your first doubt. Remember, whenever we are getting this mixture of the two products in the electrophilic substitution reaction of your chlorobenzene, of course they will not be in 50-50 ratio. 50:50 ratio ದಲ್ಲಿ ಸಿಗ್ತಾ ಇಲ್ಲ. ಹಾಗಾದ್ರೆ next question arise ಏನಾಗುತ್ತೆ? ಯಾವುದು major ಅಲ್ವಾ? Do remember guys, whenever you are getting a mixture of two products, your ortho and the para, keep in your mind a very important thing. Para products will be major, whereas your ortho products will be minor. I repeat, whenever we are talking about a mixture of the two products during the electrophilic substitution reaction of your chlorobenzene, we are going to get the two products that will be your ortho and the para substituted product. So one will be the major, another will be the minor. So which one will be the major? The para will be the major, whereas ortho will be the minor. So of course, you can ask me, why para, sir? So guys, in order to remember this, you have to see what type of a product you are going to get. Of course, if it is a solid compound, ಯಾವಾಗ ನಾವು para ಅಂತ ಬರಿತೀವಿ, basically, generally if I am going to take Cl and here also one Cl, halogenation reaction, which you will be seeing in this video itself with certain reaction. So this is what para, alva. Whereas when I am writing my Cl in the ortho position, yeah, this is my ortho product. So when we are seeing the para, you can just see its structure. It is symmetrical. It is lying in one plane itself. So it is present in a single plane. So it can easily fit into the crystal. Since it is in single plane, it can easily fit into the crystal. And one more important thing, what is that? So when we are talking about its electron density, I repeat, so of course illu electrons irutte, illu electrons irutte. So ortho position electron tumbane repulsion agakke chances irutte alva, since they are very much close to it. There will be a steric hindrance. ಏನಂತ ಹೇಳ್ತೀವಿ? there will be a steric hindrance whenever there is a two bulkier groups are present. ಅಲ್ವಾ ಆ ತರ ಸ್ಟಿರಿಕ್ ಹಿಂಡ್ರೆನ್ಸ್ ಇದ್ದಾಗ ಏನಾಗುತ್ತೆ, ಎನರ್ಜಿ ಜಾಸ್ತಿ ಆಗ್ಬಿಡುತ್ತೆ, ಲೆಸ್ ಸ್ಟೇಬಲ್ ಆಗುತ್ತೆ. ಅದೇ ಪ್ಯಾರಾ ಪ್ರಾಡಕ್ಟ್ ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ, ದ ಬಲ್ಕಿಯರ್ ಗ್ರೂಪ್ಸ್ ಆರ್ ದಿ ಗ್ರೂಪ್ಸ್ ಆರ್ ಫಾರ್ ಅವೇ ಫ್ರಮ್ ಈಚ್ ಅದರ್. ಸೊ ಅವಾಗ ಏನಾಗುತ್ತೆ, ಮ್ಯೂಚುವಲ್ ರಿಪಲ್ಷನ್ ಕಮ್ಮಿ ಇರುತ್ತೆ, ಎನರ್ಜಿ ಕಮ್ಮಿ ಇರುತ್ತೆ, ಸ್ಟೆಬಿಲಿಟಿ ಜಾಸ್ತಿ ಇರುತ್ತೆ. So therefore, whenever we are having the ortho and the para product, so therefore para will be the major, whereas ortho will be the minor. So once again now the question arises, what is that? So why does meta position, alva, meta substituted is not stable? You can ask me. So do remember guys, what happens? So whenever an electrophile, for example, if I am going to check out this one, yes, so here is my Cl, yes, and this was chlorobenzene. So here what I am getting, for example, I am doing an halogenation reaction, I am going to get as a chloronium ion, that is Cl is having a positive charge. So when it is attacking your haloarenes, do remember that we are going to get an electrophile. What I am saying, we are going to get an electrophile. So that, whenever chloronium ion is attacking your benzene ring, you are going to get an carbocation. We are going to get what? The carbocation, which will be what? Resonance stabilized. I repeat. So for example, if I am going to write it in this way, so ಈ ಒಂದು ಬಾಂಡ್ ನ ಯೂಸ್ ಮಾಡ್ಕೊಂಡು, ಸೊ ದಿಸ್ ಏನಾಗುತ್ತೆ, ದಿಸ್ ಪೈ ಬಾಂಡ್ ಇಸ್ ಇಂಟರಾಕ್ಟಿಂಗ್ ವಿತ್ ದಿಸ್ ಪ್ಲಸ್ ಚಾರ್ಜ್, ಎಸ್. ಸೊ Cl ಇಲ್ಲಿಗೆ ಏನಾಯ್ತು, Cl ತಂತು, ಇಲ್ಲಿ ಆಸ್ ಯೂಶುವಲ್ ಒಂದು ಹೆಚ್ಚು ಇರುತ್ತಲ್ವಾ, C6H5 ಅಲ್ಲಿ ಇಲ್ಲಿ ಒಂದು ಹೆಚ್ಚು ಇದ್ದೇ ಇರುತ್ತೆ. ಸೊ ಅವಾಗ ಏನಾಯ್ತು, ಈಗ ಇಲ್ಲಿ ಒಂದು ಬಾಂಡ್, ಇಲ್ಲಿ ಒಂದು ಬಾಂಡ್. ಸೊ ಈಗ ಕಾರ್ಬೋಕ್ಯಾಟನ್ ಎಲ್ಲಿ ಫಾರ್ಮ್ ಆಯ್ತು, ಎಸ್, ಹಿಯರ್ ವಿಲ್ ಬಿ ಮೈ ಕಾರ್ಬೋಕ್ಯಾಟನ್. ಬಟ್ ಏನಾಗುತ್ತೆ, ದಿಸ್ ಕಾರ್ಬೋಕ್ಯಾಟನ್ ಇಸ್ ವಾಟ್, ಇಟ್ ಇಸ್ ರೆಸೊನೆನ್ಸ್ ಸ್ಟೆಬಿಲೈಸ್ಡ್. ಐ ರಿಪೀಟ್, it will be resonance stabilized. So the same resonance stabilized carbocation is also formed when our electrophile attacks the para position. But what happens when the reaction is taking place with respect to the meta position? Do remember, such resonance stabilized carbocation will not be obtained. Though you can get a carbocation, I'm not saying you'll not be getting a carbocation. You'll be getting a carbocation, but what happens? It will not be resonance stabilized. Since we are getting an ortho and para stabilized carbocations, whenever an electrophile is attacking the ortho and the para positions, we are going to get a resonance stabilized carbocations. They will be highly stable when compared to that of your meta substituted product. So therefore, whenever an electrophilic substitution reaction takes place of your chlorobenzene, we are going to get ortho and the para product. And also in that, your para will be the major, ortho will be the minor. So next, we are going to see certain electrophilic substitution reactions. Okay, of course, you are going to have mainly 4 important reactions. One is your halogenation, nitration, sulfonation, and Friedel-Crafts reaction. In that Friedel-Crafts, once again, we are having the 2 categories, which will be dealt in my next video. But in this video itself, we are going to see 3 important reactions of your electrophilic substitution reaction, which is called as what? Halogenation, yes, nitration, and your sulfonation. So guys, now we will be looking after certain electrophilic substitution reaction. So before going to the electrophilic substitution reaction, let me remind you, of course, whenever we are doing an electrophilic substitution reactions of a chlorobenzene, you're going to get 2 products, ortho and the para, remember. And in those 2 products, of course, our para product will be major one. And why is it so? As I have explained, because whenever an electrophile is attacking our chlorobenzene, it is going to form a carbocation. So when the electrophile is occupying the positions of ortho and the para positions, the carbocation which will be formed, it will be resonance stabilized. So whenever it is a resonance stabilized, what it will be? It will be highly stable compound, and therefore these 2 products are favorable when compared to that of your meta products. So now let us look after the first important reaction of your electrophilic substitution reaction of your chlorobenzene, which is called as halogenation. What it is called as? The halogenation reaction of chlorobenzene. So what is this halogenation? Let us first see it. Remember guys, halogenation reaction is a reaction in which your chlorobenzene is treated with a chlorine. I repeat, the halogenation reaction alli enagta untu andre we are treating our chlorobenzene with chlorine in the presence of anhydrous FeCl3, that is your ferric chloride. So when we are treating this anhydrous FeCl3 with respect to chlorobenzene and the chlorine, we are going to get an ortho and the para dichlorobenzene as follows. So this is my chlorobenzene. Yes. So this one I am going to treat with what? Yes, the chlorine molecule. So in the presence of, this is very much important, anhydrous FeCl3. So what I am going to get? Yes, I am going to get the two products. What are those? One will be my para, which will be the major, plus another will be the minor. This is my Cl and one more Cl in the ortho position. So are you able to see? So when I am treating my chlorobenzene with a chlorine in the presence of anhydrous FeCl3, I am going to get the two important products. One is a para and another is our ortho. So how we can name this? So this is 1, 2, 3, 4. Yes? Yeah. 1, 4 dichloro, capital D, dichlorobenzene. 1, 4 dichlorobenzene. So this will be what? Major one. Why? Because it is a para. Whereas this is what? Your ortho. So how will you name it? 1, 2. So this will be what? 1, 2 dichlorobenzene. Dichlorobenzene. So this will be the minor. Why? Because it is an ortho substituted product. Are you able to understand? So what did we see over here? So whenever a chlorobenzene is treated with a chlorine in the presence of anhydrous FeCl3, we are going to get the two important products. One is our one is our para, another is our ortho. What is it? Para name? 1, 4 dichlorobenzene. Ortho is 1, 2 dichlorobenzene. So among this one, our para is the, yes, major one because of its symmetric nature and due to its less steric hindrance. More stability arises over there. So this is our syllabus part. Now the question arises that, sir, chlorine being an electronegative element, how can it be an electrophile? Of course, Allah. So if you are having this doubt, you have to make your eyes to go over here. So that is the reason why we have used over here as what? Anhydrous FeCl3. So what happens? Remember guys, it's a simple reaction. Cl2 when it reacts with an FeCl3, anhydrous FeCl3, anhydrous. Yes. So basically I am going to get Cl plus FeCl4 minus. So when your Cl2 is reacted with an anhydrous FeCl3, here you can see. So this itself is called as what? Chloronium ion. Chloronium ion. So whenever you are having a Cl minus, what we were calling it when you were doing the salt analysis, chloride ion. Are you able to see the difference? So when the chlorine is having a negative charge, it is called as what? Chloride ion. You have to make sure you are adding the word as what? Ion, since it's an ionic species. But when the same chlorine is having a positive charge, what it will be called as? Chloronium. Chloronium, IUM, last kalva. We have seen in the complexes lesson also. So whenever we are having a positive ligand, what is the naming nomenclature we are using? Similar case, chloronium ion. So that is the reason why I am using my anhydrous FeCl3. So by this way, I am generating my chloronium ion. Since we have got an electrophile, of course, now this has to undergo a substitution. Let me show you the ortho one, which will be easy for me and also for you to understand. So this is my chlorobenzene. Of course, now first one the mixture tagondidini FeCl to Cl2 tagonde chloronium ion siktu. So illi ningiga Cl plus bantu. Yes. So this pi electrons, it will interact with the Cl plus. So in barutilli, yeah. So here I am going to get my Cl. So here Cl and here my H. Yes or no? So by this way, plus do remember here you are having what? FeCl4 minus ಈ ಚಾರ್ಜ್ ಹಾಗೆ ಉಳ್ಕೊಂಡಿದೆ. ಈಗ ಏನಾಗುತ್ತೆ, ಸಿನ್ಸ್ ಇಲ್ಲಿ ಏನಾಗಿರುತ್ತೆ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಇಲ್ಲಿ ಬಂದಿರುತ್ತಲ್ವಾ ಈ ಕಾರ್ಬನ್ ಆಟಮ್ ಮೇಲೆ. ಸೊ ಈಗ ಏನಾಗುತ್ತೆ ಅದನ್ನ ಬ್ಯಾಲೆನ್ಸ್ ಮಾಡಕ್ಕೆ ಈ ಹೈಡ್ರೋಜನ್ ಬಾಂಡ್ ಇಲ್ಲಿಗೆ ಶಿಫ್ಟ್ ಆಗುತ್ತೆ. ಇನ್ಸ್ಟೆಡ್ ಆಫ್ ದಟ್ ಏನಾಗುತ್ತೆ ಇಲ್ಲಿ FeCl4 minus is not stable. It is trying to tie to be what? FeCl3. ಸೊ ಏನ್ ಮಾಡುತ್ತೆ ಒಂದು Cl ನ ಬಿಟ್ಕೊಟ್ಟಿ ಲಾಸ್ಟ್ ಗೆ ನಮ್ಗೆ ಏನ್ ಕಂಪೌಂಡ್ಸ್ ಬರುತ್ತೆ. ಸೊ ಯು ವಿಲ್ ಬಿ ಗೆಟಿಂಗ್ ಆಸ್ Cl ಪ್ಲಸ್ FeCl3 plus HCl. Yes or no? So by this way we are carrying out the reaction. I have just shown for which one? Ortho one. Para kuda neeven madbeku ee kade substitution ಮಾಡಿ ನೋಡಿ. Try by yourself. Of course you will be able to do it. If you have any doubt you can just ask me. No problem for that. I have just shown for an ortho position. Why I have shown? In order to make sure nothing is some mere thing we have written over just by heart. Don't do by hearting. Understand. So why we have used anhydrous FeCl3? It is acting as what? A Lewis acid. ಯಾಕೆ Lewis acid? ಕ್ಲೋರಿನ್ ಅಂತ ಬರ್ದಾಗ ಕ್ಲೋರಿನ್ ಮಾಲಿಕ್ಯೂಲ್ ಅಂತ ಬರ್ದಾಗ ಏನಾಗಿರುತ್ತೆ ಅದ್ರ ಮೇಲೆ ಇರೋದು ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಈ ತರ ಇರುತ್ತೆ. ಸೊ FeCl3 ಏನ್ ಮಾಡುತ್ತೆ ಅಂದ್ರೆ ಆ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಜೊತೆ ಇಂಟರಾಕ್ಟ್ ಆಗಿ FeCl4 ಮೈನಸ್ ಆಗಿ ಕ್ರಿಯೇಟ್ ಮಾಡ್ಕೊಂತ ಉಂಟು. ಸೊ ಒಂದ್ಸರಿ ಇದು FeCl4 ಮೈನಸ್ ಆಗ್ತಾ ಉಂಟು. ವಾಟ್ ಇಟ್ ಇಸ್ ಡೂಯಿಂಗ್? ಇಟ್ ಇಸ್ ಅಕ್ಸೆಪ್ಟಿಂಗ್ ದಿ ಪೇರ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್. ಸೊ ಅವಾಗ ಏನಾಗುತ್ತೆ ಅದು ಲೆವಿಸ್ ಆಸಿಡ್ ಹಂಗೆ ಆಕ್ಟ್ ಆಗ್ತಾ ಉಂಟು. Also along with the Lewis acid, what it is acting as a catalyst. Why is it so? Because what I have opted in the first case, at the final reaction I am getting the same case. Alva FeCl3 kuda first initial tagondite, final step allange FeCl3 I have regained it. So that is the reason it is also acting as a Lewis acid and also as a catalyst. But do remember we have to choose what? Anhydrous ferric chloride. Instead of anhydrous ferric chloride, you can also use your anhydrous aluminum chloride also. Not a big issue. You can use it. Okay. Just for a while, according to your syllabus, I have just explained it by taking my anhydrous FeCl3. So, when you're treating your chlorine molecule with anhydrous FeCl3, we're getting a chloronium ion since it's an electrophile. That electrophile, of course, it is going to react with your chlorobenzene. So, whenever an electrophile is attacking our chlorobenzene, what we know, of course, we are going to get two products. One will be our para, another will be our ortho. So among those two, which will be the major? Para will be the major and that of your, yes, ortho will be the minor. Now I would like to ask you a question. What is the main difference we are seeing with respect to the nucleophilic substitution reaction and electrophilic substitution reaction? I repeat, what is the main difference we are observing when you are doing an nucleophilic and an electrophilic substitution reaction? Yes. So when we were doing the nucleophilic substitution reaction, there we were replacing this halogen itself. I repeat, when we were doing the nucleophilic substitution reaction, for example, when you are treating with that of your aqueous NaOH, what happened? From the chlorobenzene, we have obtained the phenol. What we did, we have replaced the X itself. But in electrophilic, what we are doing? We are retaining, we are keeping our halogen like that itself, but whereas we are substituting our hydrogen part which are in the ortho and the para position. So this is the main difference you should keep in your mind. So whenever we are doing a nucleophilic substitution reaction, there we were eliminating our halogen out. But whenever we are doing a electrophilic substitution reaction, we are removing our hydrogen in the ortho and the para position. And also we are going to get a mixture of the products in an electrophilic substitution reaction, whereas a single product in our nucleophilic substitution reaction. So these are the things you have to note whenever we are saying or whenever you are observing it. Okay. So this was one of the reaction of your electrophilic substitution reaction, which is called as what? Halogenation. Why we just call it as halogenation? Because we are using what? Halogen. And do remember, only if you are taking your halogen in the absence of this anhydrous FeCl3, the reaction is quite difficult. We can say it is not possible itself. Because chlorine cannot give you as a chloronium ion in the absence of anhydrous FeCl3. So whenever you are writing this reaction, anhydrous FeCl3 has to be written. Coming to the next nucleophilic substitution reaction, which is called as nitration, which is one of my favorite reaction. You'll understand why I am saying as a favorite. So basically nitration means what? According to your syllabus, first of all, I'm just going to write how much it is important. So when I'm treating my chlorobenzene with a nitrating mixture, remember it is called as what? Nitrating mixture. What is this nitrating mixture if you ask me? So it is a mixture of your concentrated nitric acid and a concentrated sulfuric acid. So whenever I have to do my nitration, what I should do? I have to use a nitrating mixture, which is that your concentrated nitric acid and a concentrated sulfuric acid. So when I'm treating my both, that is your concentrated HNO3 plus your concentrated H2SO4, of course, I'm going to get my electrophile as what? Nitronium ion, NO2 plus. So since it's an electrophile, of course, now it is going to attack in the two positions. Yes, one will be in the para position, another will be in the ortho position. Yes or no? So one do para position substitute agide, ಇನ್ನೊಂದು ortho position substitute ಆಗುತ್ತೆ. So you just see chlorine is retained. So how can we number it, or how can we write the name? 1, 2, 3, 4. Yes or no? So according to your alphabetical order, C comes first. So 1 chloro. Next, 4 nitrobenzene. Alva, because both the substituent and that of your retained halogen were the same. So therefore I have used 1,4 di I have used. But here what has happened, the substituent is different from that of your halogen. So I have indicated their position as what? 1 chloro, 4 nitrobenzene. Whereas here what I can write? Yes, 1 chloro. This should be capital. 1 chloro hyphen 2 nitrobenzene. Yes or no? So among these two now, which will be the major? I'm asking you, which one will be the major, guys? Yes, our para will be the major, whereas our ortho will be the minor. Are you able to understand? So this is according to your syllabus. Now, of course, I have said when I was doing this is one of my favorite reaction. Why did I say it? Now, first important thing, it arises in our mind why we have used the nitrating mixture. So when you understand this one, this will be, I think you will be also like it, this reaction. So till now, what we were knowing, nitric is an acid or a base. I am asking you whether nitric, HNO3, is an acid or a base. What, sir, bullshit you are asking? Don't think in that way. When I am writing the reaction, you will only come to know. So basically, when I am talking by nitric acid, you can ask me, so why we have choose here H2SO4 also? We can only have used HNO3. You can ask me, Alva. So guys, when I am using as a nitric acid, what is your answer? What is an acid? Of course, which gives us a proton. So when I am talking about a nitric acid, of course, it is going to dissociate and it is going to give me an electrophile as H+. I repeat, it is going to give me an electrophile as H+ when I am using only the nitric acid. So of course, I am doing my nitration. So when I am talking only about the nitric acid, I am not going to get as NO2 plus as an electrophile. So one important reason I came to know that, okay, this is the reason I am using as concentrated sulfuric acid also, so that I can get my NO2 plus as an electrophile. But the question arises over here, how it will be happening. Remember guys, it's just a simple thing. I'm just giving you my simplest reactions. So what I was doing means, when I'm taking my concentrated nitric acid plus concentrated sulfuric acid, see the reaction, yes. So you're going to get as what? H2NO2 plus HSO4 minus. Are you able to see? So what you are going to get? Alva. H2NO3, sorry, NO3 alva, because here HNO3 is a H2NO3 plus HSO4 minus. Then what happens? This H2NO3 plus, yes, it is going to give dissociated to give as what? Nitronium ion plus that of your water. Alva, unless and until I am not going to explain this, you will not understand the importance of this reaction. Till now, what we were knowing was a nitric is an acid. But in this reaction, what you can see, The nitric is abstracting a proton. What it is doing? It is taking a proton. So whenever a substance is abstracting a proton, what you can say? It is acting as a base, guys. Yes. So whenever we are talking about the mixture of a nitric acid and a sulfuric acid, what we are observing is our nitric acid is acting as a base in the presence of our sulfuric acid. That is the reason sulfuric acid is called as what? King of chemicals, king of acids. Why? Because it will retain its property as an acid. Whereas nitric, till now what it was doing, only in the absence of the sulfuric acid, it was acting as an acid. But as soon as I have opted to use my sulfuric acid, what it did, it is abstracting the proton from the sulfuric acid and acts as a base. Soon after this, because of its instability, it is going to dissociate and we are going to get our nitronium ion and that of our water. So once we are getting the nitronium ion, as I have mentioned here, instead of Cl plus, NO2 plus, I am going to attack in the two positions. One will be in the ortho, another will be in our para position. So by this way, we are doing our nitration. Of course, this is some extra information I have given to you. But according to your syllabus, this much is enough. But in this much also, what you have to remember, you have to treat your chlorobenzene. If you want to do the nitration, we have to take what? Nitrating mixture. What is the nitrating mixture? It's a mixture of concentrated nitric acid and a concentrated sulfuric acid. And do remember, certain cases, 1 mark sikkira chances irutte. What is the electrophile which has been generated in the nitration and the case? It is your nitronium ion. Similarly, if they ask you which is the electrophile which is generated in halogenation, what will be your answer? Chloronium ion. Don't write as a chloride or a chlorine. Chloronium itself is the name of Cl+. So these are the simple things which you should only make as a note. Okay. So why we have used a nitration mixture? Here is my answer. Are you able to understand? So there is a reason this was one of my favorite reaction when I was doing my PU classes. Because it was an astonishment for me to know that okay, nitric acid can also act as a base in the presence of our sulfuric acid. Is that clear? So this was another important electrophilic substitution reaction. And now the most important thing and the last reaction of this video of electrophilic substitution reaction we are going to see, which is called as your sulfonation. It is called as sulfonation. So what is a sulfonation reaction? So whenever we are treating our chlorobenzene with concentrated sulfuric acid mixture, yes, what I'm going to get, Cl and here has a thrice H, and over here, okay, plus Cl and over here SO thrice H. So what is this? Yeah. So when I am numbering this is very much important amount. I am taking this one as 1 because it is taken as the parent chain and the parent carbon and the parent family. So R is in the Martin. So this will be first, second, third, fourth. Okay, priority prakara. It will be easy for me to name it. So this will be 1, 2, 3, 4. So which will be called as a 4 chloro, yes, benzene sulfonic acid. Benzene sulfonic acid. So this SO thrice H, whatever we are seeing is a what group? It is a sulfonic acidic group. Similarly over here 1, 2. So how will you name it? Yes, 2-chloro benzene sulfonic acid. Sulfonic acid. So you are going to get a mixture of the product. One will be our para, another will be our ortho. So now the question arises that how we are generating this SO thrice H. How it is coming and attacking. So in order to understand, of course, this is an extra information once again. So what happens whenever we are talking about our sulfuric acid? So basically it will be in equilibrium to give as a hydronium ion plus our SO thrice plus our HSO4 minus ion. So this will be the content whenever we are talking about your sulfuric acid in a mixture. So now what happens when I am treating with my chlorobenzene with the sulfuric acid? Of course now sulfuric acid, these quantities are present. So what it will try to do, it will first react with that of your SO thrice. SO thrice. Yav tara react agutte? Compared to a sulfur and oxygen is having the higher electronegativity. So inagutte, this will be attracted, these electrons or this bond will be attracted towards your oxygen. Instead inagutte S mele positive charge bandudutte. So that positive charge is going to interact with that of your pi electron. So illinda barutte, illinda barbeku. So see, my arrow mark is always from negative to positive side. So if again aguttilli, so you will be getting as what? Yes, here will be my Cl. So it has used that pi bond and it has formed what? S, double bond O and an O minus. So here is my bond. I'm just showing my one part. So next what it is going to do, yes. Now whatever your HSO4 minus is there, yeah. Illenagirutte one H hage ulkondiruttalla. Plus, so now here you will be having a HSO4 minus. I'm going to write it in this way. The structure of HSO4 minus is in this way. HSO4 minus. So what this minus will try to do, it will try to abstract this proton. So aವಾಗ ಬರಿ ಪ್ರೋಟಾನ್ H ಪ್ಲಸ್ ಮಾತ್ರ ಹೊರಗೆ ಹೋಗ್ತಾ ಉಂಟು. ಇಲ್ಲೇನಾಗಿರುತ್ತೆ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಇರುತ್ತೆ. ಇದನ್ನ ಬ್ಯಾಲೆನ್ಸ್ ಮಾಡಕ್ಕೆ ಏನ್ ಮಾಡುತ್ತೆ, ಇದು ಒಳಗಡೆ ಬಂದ್ಬಿಡುತ್ತೆ. Are you able to see? So ಅವಾಗ ಏನಾಗುತ್ತೆ, yes. So here I am going to get as what? Cl, and here I am going to get as what? S double bond O and an O minus. So here and here I am going to get, do remember what I am getting back? Yes, H2SO4. So H2SO4 is acting as a catalyst. But what has happened here? Minus is there. So of course again agite SO3 no use aitu, HSO4 minus also used, which was present in the mixture. Again agite H3O plus is also there. So that will be now reacting with this. H3O plus will be reacting. Again agute one H will be taken. So we'll be getting the final product as what? So Cl and over here as SO thrice H. Are you able to see? So this is the reaction which is taking place actually, plus our water. Can you see? So whenever we are talking about your sulfuric acid, you will be having your hydronium ion, your sulfur trioxide, and that of your ion of, what you can say, bisulfate, alva? HSO4 minus, bisulfate ion. So avagena, so this is going to react. So first SO3 jute react agutte, since the electronegativity between S and O is very high for oxygen. So that will be, electrons will be shifted towards the oxygen. So oxygen will be having the delta minus, S will be having the delta plus. So utilizing that delta plus phenomenon, what it will try to interact with the pi electron of your benzene, and it will be resulting in an SO3 minus. By utilizing whatever the bisulfate ion was there, that is going to interact with your proton as H plus, yeah, which will present to that of your benzene ring. It is going to abstract that hydrogen and bond will be favored. But what will be happening? SO3 minus that will once again react with that of your hydronium ion which is present in the system to give our sulfonic acidic group. Are you able to understand? So by this process our sulfonation takes place. But for your exam, of course, this is not needed. What I am given is an additional information. Instead of by hearting, you will come to know that why we have written the particular products. So two important things I have to now mention over here. So in your exam, whenever we are writing, or whenever you have been asked to write halogenation, nitration, sulfonation, any named reaction or any reaction, do remember, first you have to explain the reaction in words. I repeat, first you have to explain the reaction in words, and then you have to write the reaction. Even though it is for 1 marks, 1 marks they will only mention, just give the reaction. If it is for 2 marks or 3 marks, the marks will be distributed. If you write only the reaction, only the half of the marks would be given. For example, 2 marks means 1 mark will be for your explanation. Of course, which I have not written, but I have said it when I was explaining it. So first you have to write it in theoretical way. That is nothing else, whatever the reaction you have written, the same thing. For example, for sulfonation, when chlorobenzene is treated with a concentrated sulfuric acid, ortho and the para chlorobenzene sulfonic acids are obtained. Write it in words. Then you write the reaction. If you're not able to write it in words, what you do, leave on 2 to 3 lines. First you write the reaction. By seeing the reaction, of course you can write the reaction in your words. So this is the first important thing. Second most important thing, what is that? So whenever we are writing our products, of course, chlorinic bardaga, ಆ ಬಾಂಡ್ ಯಾವ್ದಕ್ಕೆ ಜಾಯ್ನ್ ಆಗಿಬಿಟ್ಟಿತ್ತು? ಎಸ್, in that Cl it should be linked to the C itself. There is problem illa. Other some of the times what you do is, when you are writing as a chlorobenzene, for example Cl idre, what you will do, you will be writing in this way, NO2. This is wrong. This is wrong. Why it is wrong? You can just see that whatever the electrophile is generated, it's the positive charge is on the on the nitrogen atom and not on the oxygen atom. I repeat, whatever the electrophile we have been generated as a nitronium ion, there are positive charges on the nitrogen atom, not on the oxygen. So when you are writing in this way, so what does it indicate? Okay, positive charge was on the oxygen atom. The chemistry itself will be wrong. So therefore you have to make sure that whenever you are writing the substituent, you should be aware that which atom is bonded. Which atom is bonded. Similarly in sulfonic acidic also, sulfonation ಮಾಡಿದಾಗ what you will be writing? You will write in this way, SO thrice H, or some of the fellows are so lazy that they will be writing this way, SO thrice H. These are all the wrong way of writing. Yake, here itself we have seen electrophile is acting as which one? Delta plus ಬಂದಿದೆ ಯಾವ್ದ್ರ ಮೇಲೆ? ಸಲ್ಫರ್ ಮೇಲೆ ಅಲ್ವಾ? ಆ ರೀಸನ್ ಇಂದ ಏನಾಗುತ್ತೆ, the pi electrons has to interact on that sulfur itself. Okay, because when you're writing as an oxygen, of course it is not possible. Minus will ripple. So whatever this way of writing, whatever the return part shown madidinalla, so both will be the wrong concept. Concept will be itself wrong. So you have to make an uttermost care should be taken whenever you are writing these substituents. So it has to be binded with respect to our sulfur atom itself. Why ಅಂತಾನೆ ಹೇಳಿ, ಅದಕ್ಕೆ ಅದೇ ರೀಸನ್ ಇಂದ ನಾ ಮೆಕ್ಯಾನಿಸಮ್ ಕೊಟ್ಟಿರೋದು ನಿಮ್ಗೆ ಇಲ್ಲಿ. ನಿಮ್ಗೆ ಕಾಣ್ತಾ ಉಂಟು, ಆಕ್ಸಿಜನ್ ತಗೊಂತು ಎಲೆಕ್ಟ್ರಾನ್ ನ ಸಲ್ಫರ್ ಮೇಲೆ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಬಂದಿರೋದು. Sulfur atom itself is having the positive charge, so it has to only interact with that of your benzene. That is the reason bond will be also favored with respect to the sulfur atom itself. So uttermost care should be taken. Don't do the silly mistake and lose your marks. Okay. So this was a certain important electrophilic substitution reaction. And what are the two things we came to know? Major important things. Whenever we are doing an electrophilic substitution reaction, we are going to get two products. One will be our ortho, another will be our para. And in that two products, our para will be the stable one. And do remember, never forget to write both the products. Sir, bari major bardre saaka anta nimma question idre, it will be a very silly question to be asked. Remember, you have to write both the products, and on top of that you have to write its name and also which will be major, which will be minor. I repeat, whenever we are writing an electrophilic substitution reaction, the products, both the products has to be written along with their name and along with mentioning which is the major, which is the minor. And keep in your mind, always para will be the major, ortho will be the minor. Is that clear? In this case, in certain cases it can be a twisting also, but I'm not going to explain it now. I don't want to confuse you. Just to remember that whenever we are treating our chlorobenzene with an electrophile, we are going to get an ortho and a para product. Para will be the major, ortho will be the minor. So in my next video, we are going to see the next electrophilic substitution reaction. That will be a Friedel-Crafts alkylation and Friedel-Crafts acylation. Okay.